Today we're going to go over direct and inverse variation. You ready, class?
Yeah!
Game up?
Yeah!
Alright, pretty good. Next time do it together. Okay, so today we're going to do direct and inverse variation. The definition of direct variation is marked by the following formula. Direct variation means, okay, first write this formula. The way you'd say this is y varies directly as x, or y is proportional to x. If you see varies directly, see it here? You see varies directly, or y is proportional, what it basically means is as y goes up, x goes up. All right, so think of the things that you know. When one thing goes up, another thing goes up. The technical term for that is varies directly. All right? So what happens is y is going up and x is going up, and this k stands for constant. I don't know why it's k, like they can't spell constant, but yeah. So this is a constant term. So pretend you can't spell and you think, you know, cat is spelled K-A-T and constant is spelled with a K also. Alright, so if I said y varies directly as x, this would be your formula. If I said a varies directly as b, what would your formula be? A varies directly as B.
A equals KB.
Yeah, A equals KB. Right? This would be A varies directly as B. Or A is proportional to B. Okay? So now, we'll leave that there. It says, the tension T in a spring varies directly as the distance x it is stretched. So T varies directly as x. So T equals kx. Right. So the formula goes T equals kx. So let's think about a string, or a spring, I should say. Okay. Would you agree that the tension in the spring is more when you stretch it more? When you stretch a spring, and it goes like that, the tension's more when you pull it. So that's what it means, varies directly. The more you stretch it,
the more tension.
The more tension, yeah. The more distance, the more tension. Okay? So here's the problem.
If T equals 8, when x equals 2 inches, alright, find T when x equals 4 inches. Alright.
So first step, when you see direct varies directly, you think of a formula like this. You create your formula. Okay, so the next step is to plug in and find our constant. The constant's the key, all right? So if you want to write that in your notes, you could write, find the constant. Determine the constant. So let's look at it. If t equals 8 when x equals 2, we plug in 8 and 2. So instead of t, what are we going to write? 8. Good. 8. And we're looking for k. Instead of x, what are we going to write? 2. Solve for k. Bless you. Solve for k.
Divide both sides by 2.
Divide both sides by 2. Good.
K equals 4.
K equals 4.
So why is 8 the constant?
Oh, 8 is not the constant. 8 is t. 8 is t.
Oh, yes.
All right? So we plug in our first scenario to determine what k is. So now we have k. The constant is 4. 4 is not going to change. And now from here, we rewrite the equation. T equals kx, but t equals 4x. All right. So we have our new equation with a constant known. Is that a question? No? Okay. Now it's saying, find t when x is 4.
So plug 4 into x.
We're done. Yeah, we said plug 4 into x and we're done. Okay, so x equals 4 is going to go into here. So t equals 4 times 4 equals 16. Problem solved. Yeah, someone said it's easy. Like, it's easy if you know what you're doing. It's process oriented. Are you ready to try one yourself?
Yeah.
Okay, so I'm going to erase this magically
Wait.
and show a new problem. All right, here we go.
Supposed to be.
Whoa! Oh my God! How did that happen? Did someone write that? Knock me out? Okay, never mind. Okay. Anyone read the Da Vinci Code or watch the movie? Anyone?
That was so bad.
Okay. So, but this is an interesting observation. I read the book. It was good. Da Vinci observed that a person's height varies directly as the width of their shoulders. Stop there. Height varies directly as shoulders. So what's the formula? Height, what do you want to call height? H. H varies directly as
KS.
KS, S for shoulders. Okay, you want to do width or S? Let's do width.
W.
Yeah, let's do width. We did height. We're going to do width.
So KW.
KW. Yeah. Good. H equals KW. All right, so next sentence. If a person's 70 inches tall, so that's their height, has a shoulder width of 17.5 inches. Stop there. So, 70 inches tall, where does that go?
H.
H, good. 70 equals what?
K times 17.5.
K times 17.5. I need a calculator person.
Ellie.
All right. So what do we do to both sides?
Divide by 17.
Divide by 17.5. Can you tell us what that is, please? You got it.
4.
4. Again, how about that? K equals 4. Okay. Who remembers the next step? Yeah. Anyone else remember the next step? Once we got our K,
Plug it in.
plug it into the original equation. Right? No, don't say duh, you're learning. It's cool. It's cool. H equals K dub. H equals 4 dub. Bull you. Okay.
Bull you.
Yeah. Thank you. All right. So what's the height of someone whose shoulder width is 16?
So 4 times 16.
So 4 times 16, correct. So let's plug it in. H equals 4 times, our new width of the shoulders is 16 inches across. 4 times 16, you know, is?
64.
64. Quick math. H equals 64. 64 what?
Inches.
Inches.
Duh.
Any questions on direct variation?
Nope.
No.
That's the idea. All right, you want to do a different problem now? It's going to be inverse variation, same type of problem. All right? So I'm going to huff and puff and blow this problem off the board. Ready? Oh, wow. Okay, that was cool. Magic is nice. All right. So the length L of a rectangle is inversely proportional. Inversely proportional to the width. All right, so new formula. Inversely proportional means as one goes up, the other goes down. Right? That's an inverse proportion. Okay? Direct proportion or direct variation, both went up or both went down. This one's opposite. Here's how the formula for this goes. Y equals K over X. If you see inversely proportional, you're thinking this type of formula. However, in this problem, it's not going to be Y and X, it's going to be L and W. All right? So in this problem, this would say Y is inversely proportional to X. Or Y varies indirectly to X. Okay. So here, inversely proportional. Now it says the length of a rectangle inversely proportional to the width. So length inversely proportional to the width, what would the formula be?
K over
L equals
K over
K over W. Length is inversely proportional to width. That's the formula there. And we apply the same rules we did last time. That's all. All right. So let's look at it. If the length is 6 feet when width is 2 feet. So let's plug in. Instead of length, we're going to write 6. Any questions on this? Feel free. Okay, 6. Instead of W, we're writing 2. Why is only one person responding? Oh, is it Wednesday? Is that what it is? Hump day? Well, get over that hump, boo. Okay. What's K? What's K? Cross multiply.
It's 12.
K is 12. Good. So K. What does K stand for?
Constant.
Constant with the K. All right. So K
And
is
the
12.
constant is the key.
Then you do the
Constant's the key.
And the
Fine.
key starts
12
with
over
the K.
2
Good. Huh?
equals 6.
All right. Thank you for that. Let's stay focused on the math. All right? That's a deterrent to the learning. I hope you realize that by now. All right, so L equals 12 over W. Find L when W is 3. Yes?
So you do K, 12 over 3.
12 over 3
Equals 4.
says find L when W is 3. So W is now 3. So L equals 12 over
3.
3. So what's L?
4.
4 feet, yo. Any questions on that?
Nope.
No? All right, so to recap, if I said y varies directly as x, what would the formula be? Y varies directly as x, what would the formula be?
Y equals K to X.
Y equals kx, correct. So let's put that up here. Direct is y equals kx. And if I said y varies indirectly or inversely,
Y equals K over
y equals k over
X.
x. That's all it is. And then you plug in to find k. You say then find k. Okay.
Yay.
That's all. Thank you. That was fun. Okay, you can cut it. Bye, world!